Today we're going to talk about one of the most famous theorems in all of mathematics, the Pythagorean theorem. And so it was developed by a man named Pythagoras, and it is used to find missing sides of right triangles. So if we look at this triangle here, and we say that this side is A, and this side is B, and then the hypotenuse is C, then the Pythagorean theorem states that the square, so a squared, plus b squared is equal to c squared. And so the square of the two legs, the sum of the square of the legs of a right triangle is equal to the square of the hypotenuse. Hypotenuse. So a squared plus b squared equals c squared. And now we can use this in lots of ways, and we'll use this in some real world type of applications here later, but today we're going to use it to solve some problems where we're just simply trying to find a missing side of the triangle. Now, one only thing you're going to need to know is that the opposite of finding the square of a number is the square root of a number. And so this symbol here, that is called a radical. And so when you see a radical undoes squares. So kind of like multiplication would undo division, or addition might undo subtraction. A radical undoes a square, or vice versa, a square undoes a radical. So what that means is that when you're looking for side C, you're going to do a squared plus b squared equals c squared. And so then what you're going to wind up doing is, if you have a squared and b squared, you're going to put a in there, and it's going to be a times a plus b times b is equal to c squared. And then once you get this whole number here, a times a plus b times b, then you have to take the square root of that side and of this side, and then that will give you what c is. So I know that sounds crazy right now, so let's see it in action. All right, so here's our first example problem. And now, one thing we need to point out is that this is the hypotenuse, so this is side C. Okay, so it doesn't really matter. A and B doesn't really matter. It's fine. All right, so this one is going to be 9.4 squared plus x squared equals 13.1 squared. All right, so if you are a math wizard, maybe you can do these in your head. Otherwise, pull out your calculator. 9.4 times 9.4, or if you have a squared button, you can use that. And this is going to be 88.36 plus x squared is equal to, and then 13.1 times itself is going to be 171.61. All right, so now I can subtract 88 and 36/100ths from both sides. I should be left with x squared on the left-hand side, and 88.36 is 83 1/4 on this side. So now I'm going to take a radical, and I'm going to remember with algebra, whatever you do to one side, you have to do the other side. So I'm going to get x, and then to find this, if you're using your calculator, you type in 83.25, or if you already have it in your calculator, then turn your phone sideways, and there's a button that looks like this. It's got a square or a radical. It's got an x inside of it, and it's got a little 2 on the outside. This is the button that you're looking for. All right, so when I do that, I get 9.1. All right, so 1 decimal place is sufficient for this. And I'm going to add my kilometers. Okay. All right, so this one, this is the hypotenuse, so that's C. So then you just have A and B. Always label them or else you'll get confused. All right, so 6.9 squared plus 4.8 squared is equal to x squared. All right, so I don't know what these are. 6.9 times 6.9, or use your square button. It's 47.61. 4.8 times itself is 23.04 equals x squared. So add those two together. So 47.61 plus 23.04, and you get 70.65 equals x squared. Now I'm going to do my radical, my square root, and I'm going to see that this is going to be x is equal to 8.4. Okay, and this is also kilometers. All right, so each time, remember this was just a squared plus b squared equals c squared, and I just plug and chug these in here. So a goes into where a should be, b goes where b should be, and then c is just the x squared over there. All right, that's it for today.